Maybe I should. All right, today for geometry, we have 4.3. We're talking about congruence postulates, which are fun things. Okay, yes, they are. All right, so first of all, to prove triangles are congruent, okay, to prove the triangles are congruent, using the definition of congruent triangles, you must show there are 6 pairs of corresponding angles and sides are congruent. That's if you want to use the definition of congruent triangles as your reasoning. If you want to do that, then you have to prove that all of those are equal. Now, the nice thing is that you don't have to do it that way. There are lots and lots of shortcuts on the treasure map. Okay, so the first one is the side angle side. Okay, that's side angle side, which we call SAS oftentimes. Oh, it's over there. I forgot. It's over here. It's the SAS, congruence. Okay. All right, so what that means is if 2 sides and an included angle of a triangle are congruent, then to the corresponding 2 sides and included angle of another triangle, then the 2 triangles are congruent. All right, so let's look at this. There's a picture there. So we have 2 sides. ST is corresponding to PQ. UT is corresponding to RQ. All right, and they both have these congruent marks. So we have 2 sides that are congruent. And then it says an included angle. That means the angle in between them. That's the included angle. The other 2 are considered excluded, like they're not part of it. Does that included term make sense now? Okay, so if you have this, if you have 2 sides, if you have a diagram that looks like this, right? You have 2 triangles that look like this, you can say that the 2 triangles are congruent. The whole thing. You don't have to prove all 6 sides are congruent and all 6 or that all the angles are congruent. You don't have to prove all of that if you're using side angle side for your reasoning. Okay? That's only if you're using the definition of the congruent triangles. Now we also have another one, which is the angle side angle congruence postulate, or it's ASA. Okay, so this time we need 2 angles and the included side to be congruent. So let's look at the breakdown there in this diagram. So angle H is congruent to angle D. That's one angle. I'm going to say angle I is congruent to angle E. So that's my second angle. And I have to have an included side. So the side between those must be congruent. So that's HI is congruent to DE. So I have a side in the middle, just like in ASA. It's an angle, then a side, and then an angle. If I have that, then the 2 triangles are congruent. Okay, and that's the other thing, like let me go back up here to this with side angle side. I had to have a side that was congruent, then I had to have an angle, and then I had to have the other side. They have to be touching. Okay, they have to touch. So does that idea of included make sense? Yeah. Like they're all in a row or they're consecutive, they're included. Okay, fantastic. So the next thing says compare the side and angle postulates. Yeah, just compare them. Like what do they have in common, or what do they have that are different? Let me clear this and move it up. Okay, so let's do this. Let's do side angle side. What do they both have? And what does angle side angle have? Does that make sense? Okay, so what'd you say they both have? At least one congruent angle and one congruent side. So how about we say they both have 3 congruent parts? Yeah, sure. Okay, so 3 congruent parts. And then we could say, well, side angle side has two congruent sides, one congruent angle. Whereas this one has two congruent angles and one congruent side. Does that make sense?
Yeah. Do we need more than that, or?
Just do you guys see anything else? That's important that you have three congruent parts.
If they both will show that a triangle.
Oh, they both show, okay. So they both prove, we're going to say prove two triangles congruent. How about that? I'll squeeze it in. They both prove that two triangles are congruent. That's good. It's like they're both shortcuts. Woohoo! Let's sing about that. Hallelujah. Hallelujah. I mean, those are good things to notice. Anything else?
They don't work unless it's not true. They don't work if it's not true.
They don't work if it's not true. Well, that's true. They don't work if it's not true. So we want it to be true. All right, I think that's good. Let's go. You guys did a great job. On down to the examples. All right, so example 1 says, what additional information is needed to prove that triangle CAB is congruent to triangle CED?
Yeah.
By the given congruence postulate. Yeah, we did kind of in our warm-up. All right, but we want to use this postulate. Okay, so it says, how do we prove it with the SAS? Okay, so side angle side. So we currently have that a side is known, right? Okay, so if this is our side that we know, and we want to use side angle side, what angle do we need to know is the vertical angles? I did start to say it. Okay, so we want to know that this angle, ACB, is congruent to this angle, ECD. So that's what we've got. We need an angle congruence. So side angle side, what side do we need then?
Could you do side DE and side AB?
Okay, if we did DE, is that side with the angle in between and a side? If we did side DE, you said, right?
Yeah.
Is that side touching an angle that's touching the other side? Is the angle in the middle of the two sides? So we can't do side DE. It would have to be, okay, so it would have to be that we do CD is congruent to CB.
But how do you know that?
Because if we're using the side,
the angles are the same, the side would have to be the same.
yes, yes. Okay. So does this make sense of why we chose those three, like that, those two sides and those two angles? Okay, so now we want to prove it using angle side angle. We can, because we said what information do we need is needed. What information is needed? Would we need to know? So this we're doing angle side angle. So if we have this side, right, these two sides, so that's our side, right? The side is in the middle, so we need the angles on both sides. A is an angle. Yep, because it's not, when it's not an angle, like we can't say angle B here because angle B is split into two parts. There's this part and there's this part. Does that make sense? But like this, if this was angle A, there's just one possible angle there. So we could call it angle A. This one would have to be ABC, and this one would be CBD, would be this one. Does that make sense? Okay. Sorry for the sidebar there. Okay. So back to this one. If we're proving using angle side angle, we already know the side that's given. So we have to choose the angles. We have to prove the angles on both sides. So again, we could say, what'd you say about angle A? Did you say, could we call this angle A? Okay, so angle A would be congruent to to angle E. Good. All right, so that one's there. And then what are, no, we need two angles. So we got one angle.
Do the vertical angles.
Then we do the, yeah, so we do the vertical angle. So angle ACB, we need to prove is congruent to angle ECD. And then we have, if we look at that, we have an angle over here, a side, and the other angle. So we did angle, touching a side, touching an angle. We proved congruence. But they have to be in order. They can't just be any random angle, any random side, and any other random angle. They have to be in order. They're all touching. Okay. Let's see, example 2. If segment AB, whoop, sorry about that. And well, we were using them earlier in class, but now it doesn't like to let me move them or erase them. So unless I clear the page. Okay. So example 2, if AB is congruent to ED, so AB is congruent to ED, can it be proved that triangle CAB is congruent to triangle CED? Okay, so at this point, we have two congruent lines, and we know these are congruent because they're vertical. We know they're congruent, so we know this. So we have an angle, a side, and another side, so side, angle, side. So can we prove that these are congruent? No, we cannot, because side, angle, side, it has to be the side touching the angle that touches the other side. They're not touching. This side touches this side, but we don't know anything about this angle here. So no, because it's not the included, right? Okay, so if we look at it that way, they're not included. So does that make sense? Again, they have to touch. Goes side, touches, angle, touches, side. We got it? Okay, we're clear as mud? Nothing. Mud's not clear, guys. Come on. Okay. We do have a back. After two triangles, are shown to be congruent. So after they're shown to be congruent, the definition of congruent triangles can be used to state that any of the other pairs of corresponding parts are congruent. Do you remember this? CPCTC? Did we talk about that yesterday? Yeah. You're going to want to remember it. Like write it down, highlight it, get a tattoo, whatever you need to do. Okay? Because we're saying, so after two triangles, that's it. After two triangles are shown to be congruent, so like angle, side, angle, we proved them congruent. Then we can say, well, hey, then this part is congruent to this part because corresponding parts of congruent triangles are congruent. That's what that means, right? Corresponding parts of congruent triangles are congruent. I don't know why my P didn't get traced over. All right, so let's look at this that we have, this proof. So we have given the figure, prove that angle M is congruent to angle O. So we want to prove M is congruent to O. All right. So we knew that LM is congruent to LO, so our side lengths, and angle MLN is congruent to angle OLN. Okay, those are marked. So that was given. Well, we could say LN is congruent to LN because of that reflexive property of congruent segments. Now, though, we suddenly have a side, angle, side. Side, angle, side. So we have side, angle, side. We could say these two triangles, triangle MLN is congruent to triangle OLN because of side, angle, side. Now that we have proved the two triangles are congruent, we can say angle M has to be congruent to angle O because corresponding parts of congruent triangles are congruent. So we took a lot fewer steps than we would have to otherwise. It is a kite on the next one. And it spells kite. Uh-huh. Questions about this proof? And how we used angles or side, angle, side? Okay, so let's look at 4 then. So we're given that IE bisects angle KIT and angle KET. What does bisects mean? What does it mean? Cuts through it? Bisects it. What does bisects mean? What? You got a glossary or in the back of your book you can use? It shouldn't be hard to explain bisect. I'll tell you, it says see segment bisector or angle bisector. Which one is this? Is it a segment bisector? An angle bisector. So what's an angle bisector?
It's when a line's cutting into one angle to make it two angles.
Okay, it's when a line cuts into an angle to make it into two angles. Is that the best we got? No. Array what?
Array that is in the interior of the angle that forms congruent adjacent angles.
Oh, that's the key. It forms congruent adjacent angles. If we know that IE bisects KIT and KET, it means this angle is congruent to this angle, and this angle is congruent to this angle. Yes. Okay, that's huge.
And then that you know that the bisecting line.
Okay, hold on, just a second. So that's how we wrote down what we had for the given, but that's where we made this leap for step 2. The definition of an angle bisector means that angle KIE is congruent to angle TIE, and angle KEI is congruent to angle TEI. Because we know a bisector does this. It cuts it in, an angle bisector cuts the angle into two congruent angles. Okay, so now we've got two angles that are congruent. Man, I feel like angle side angle, right? Like angle side angle needs two angles. If I look at this, if I look at one triangle, like KIT, or KIE, pardon me, I have an angle here and an angle here. What side do I need to be congruent? The middle one. And that would take care of both triangles, right? Because it's a side for KIE and the blue line is a side for TIE. Can we prove that IE is congruent to IE? They're the exact same thing, yeah, but that's how we got to the next step. Okay, it's the reflexive property. IE is congruent to IE. And so now you have an angle, an included side, and another angle. So the angle touches the side that touches the next angle in both triangles. So we can say that, step 4, the triangles are congruent because of the angle side angle. And then we can say, well, again, once I prove that they're congruent, I can use that corresponding parts of congruent triangles are congruent, and I can prove what they are looking for. That segment or side KI is congruent to side TI. So what do we think? I feel like we started off really well, but like we hit the proofs and it's like we just kind of hit a wall because they were already filled out. Should I not have them filled out in the future so we can talk about them a little more? Possibly. Would that, you think, help? Okay, because I'm trying to decide, like, is it better to give you the proof, or is it better for us to, so we could talk about it, or for us to figure it out? All right.
Or like harder ones, or like ones that we just learned today, keep on there, but like ones that we've already should have known, take off.
Okay. Okay, we'll see how that goes. Because this is ones that we just kind of worked on today, so that was like why I included them, but maybe I should have left them off. All right, well then let's get started on your homework. That's it for today. Because again, I'm trying to find a way for us to get more time to work in class and work through some of them. So